everyone. So we're going to talk about something a little bit different here, radical equations. Now we're actually going to be talking about this entire unit. There's going to be about 4 videos on it where we're doing the same thing, but we kind of increase the difficulty each time. So here are some equations. Now, some of these are radical equations, like this first one and the third one, while some aren't, like the second and fourth. And I want you to think about, well, what makes an equation a radical equation? Well, if you look at here, it's not just the fact that it has a radical, as all of these have radicals, but it's when this variable underneath the radical. See, over here for the second one and the fourth one, the radical is actually on the number while the variable is outside of it. That's the main idea. Now, when we have a radical equation like this, where a variable is underneath the radical, there's a few steps that we have to take. Now, the first thing that we want to do is isolate the radical. So we basically just move everything over to one side until we have the radical on one side and then everything else on the other. So let's take this equation for example. We have the square root of the x minus 3 underneath the square root, and then we have the 3 and the 10 over here. We are going to move the 3, subtract 3 over to the other side to get the square root of x minus 3 equals 7. Next, what we're going to do is square both sides. When we square this radical term, it gets rid of the square root. So we are left with x minus 3. When we square the 7, we get 49. So now we have x minus 3 equals 49. From there, we just solve the equation. So move the 3 over, and we get x equals 52. Now, the main thing that we want to do after we do this, we have to check our solutions to make sure that none of those solutions are extraneous. I'll explain what that means in a second. So in this case, we got x equals 52. I need to make sure that this is a proper solution. So I plug it back into the original equation. I put 52 in for x. So now I have square root of 52 minus 3. When I do the math, that's square root of 49. Square root of 49 is 7. 7 plus 3 is 10, which fits. So I know for a fact that x equals 52. Now, what do we mean by these extraneous roots? Well, it happens that when we solve these equations, once we square both sides, what we end up doing is accidentally creating a second solution that may work. But when we plug it into the original equation, we find that it actually doesn't work. So we need to check at the very end. So here's an example of what that is. So if you go and try and solve this, you'll end up finding that you have two solutions, x equals 5 and x equals 10 when you get to the end. But when you plug these numbers back into this original equation, you'll find that when you do x equals 5, you end up with 6 equals 2, which doesn't make sense. But over here, when we do x equals 10, we actually do end up with a true statement, 7 equals 7. So what this tells me is that x equals 5 is my actual solution. X equals 5 is not. So you have to pay attention. So here's just an example of what it means when we square it. So here first, you just want to solve this solution. So as you could probably tell already, we can just add the 1 over to the other side, and we get x equals 5. All right, so let's say that we decided to go a little bit crazier and square both sides of the equation. So we have x minus 1 squared equals 4 squared. When I expand this out, this becomes x squared minus 2x plus 1 equals 16. Well, in order to solve quadratics, I have to move the 16 over. And then what I can do is I can factor this, and I get x minus 5, x plus 3. When I solve this, set both of those factors equal to 0, I get my two solutions, negative 3 and 5. So in this case, I'm still doing the correct math. I'm still doing proper math, but now I have a second solution. So like I said, a lot of times when we end up squaring, we'll end up with a second solution. It doesn't always happen, but usually, we just want to make sure. So we take our two solutions, x equals negative 3 and x equals 5, and we find that x equals 5 is actually my only true solution. So x equals -3 is not a real solution. Now, there is actually one more thing. I think I say this later on, but when we go to plug the numbers back into the square roots in our original equation, we're always going to take the positive square root. So here we have another example. So let's say that we want to actually work with this one. So what do? Well, once again, we isolate the radical term. So we're going to move the 2 over to the other side. We get this. Expand out x minus 2 squared to get x squared minus 4x plus 4 equals x plus 18. I move the x and the 18 over to the other side. And then I can either factor this or use any of my solutions to find two solutions for this equation. From here, when I set these two factors equal to 0, this gives me x minus 2 and x equals 7. So taking these and plugging it in, we end up seeing that when we plug -2 into our original equation, I get 6. And when I plug in 7, I get 7 like I should. So again, only one of these is the true solution. And like I said before, we're only taking the positive square root. Remember, technically when we do square root, it's always plus or minus, but we're going to ignore that. That's actually called the principal square root. So when we take only the positive, that's what we're looking at. All right, so here's our first solution. Pause the video, work itself, and we'll go over it in a second. Okay, so what we're going to do now is follow the steps. The first step was to isolate the radical, which it is. The radical term is all on the left side. Everything else is on the right. So now what I can do is go to the second step where I square both terms. Now, when I square this square root, it gets rid of it. So all I do is just erase the square root. And then here, I raise both x plus 3 to the square. Now, again, do not distribute the square. You need to make sure that you write it out as x plus 3 times x plus 3. In fact, I really recommend that you try to remember how to do squares like this of binomials, because it will make this entire process a lot easier. But what you can do is you can distribute the terms. So you can distribute x to both terms and the 3 to both terms. And you'll end up getting x squared plus 6x plus 9. Now, like I said, there is a shortcut. So if you're doing x plus 3 squared, the solution is going to be x squared plus 2 times 3x plus 3 squared. And the thing is, it doesn't matter what the second term is. If instead of a 3, it was a 4, oh, then all this does is this becomes 2 times 4, and then this becomes a 4 squared. So you can, if you can remember this, it makes the whole process a lot easier. But then from here, I have an x squared over here, so I can cancel them out. I have a 9 over here and a 9 over here, cancel them out. So what I'm actually left with is 0 equals 6x, or x equals 0. Again, we want to check our solutions. So we plug in 0 into our original equation. Underneath the radical, we just get rad 9, and then on the right hand side, we get 3. This gives us a true statement, 3 equals 3, which means 0 is a solution for x. So again, once we solve it, we have to do the check, and if we come up with a true solution, or true answer, then that means our solution is correct. All right, here's the next set. Pause the video, work itself. We'll go over in a second. All right, so from here, again, the radical is isolated, so we square both sides. We get 4x equals 6 squared, which is just 4x equals 36, and x equals 9. Do our check. So we plug the 9 into the x and multiply it by 4. 4 times 9 is 36. The square root of 36 is 6. Therefore, 9 is a solution. All right, like I said, this first video should be more focused on like the simpler types, and then each video after will end up being a little bit tougher. Again, this is isolated, so I just square both sides right from the get-go. Remember, the square of a negative number is always positive, so square of 4 is 16. Subtract the 8 over, and we get x equals 8. Now when we check this one, we plug 8 into underneath the radical into the original equation. We get square root of 16. But remember, we always take the positive. So when we do the square root of 16, we end up getting positive 4. Positive 4 equals negative 4. That doesn't actually work. So that means that there are no real solutions. Again, we have to make sure we check because sometimes we don't always get the solution. And you also have to remember that we always take the positive square root. All right, here's the next step. Pause the video, works up. We'll go over in a second. All right, so before I can solve this, I actually do need to move the 3 over to the other side. So when I move the 3 over, I get 7. Then I square both sides, and I get 2x minus 1, gets rid of the square root, equals 7 squared. That's just 49. So from here, I can add 1 over to get 50. So 2x equals 50. Divide both sides by 2, and I get 25 for x. Just checking to make sure this is a solution. I put 25 into the original equation. 2 times 25 is 50, minus 1 is 49. So now I have the square root of 49 minus 3, which is just 7 minus 3, because square root of 49 is 7. And this has to equal 4. 4 equals 4, so this is a real solution. All right, and then for number 4, this one's simple. We actually have square roots on both sides. So when we square, it just gets rid of the square roots on both sides. So it actually ends up becoming a lot easier. We just end up with 5x plus 3 equals 3x plus 7. Move the 3 over, and then on both sides, I guess. So we subtract 3x from both sides, and we subtract 3. And we end up getting 2x equals 4, or x equals 2. Doing our check, so multiply 5 times 2 and multiply 3 times 2. So we end up getting root 10 plus 3 equals root 6 plus 7. Just finishing this through, we end up getting square root of 13 equals square root of 13. That's a true statement. Therefore, x equals 2 is a real solution. All right, and that's pretty much it for this. Like I said, we're going to do a few more complex setups, but as long as you kind of follow this path of isolating the square root term and then, following the steps like that, you might have to pull out some quadratic solutions like quadratic formula and completing the square. If you have any questions, please let me know. Otherwise, I'll see you later. Good luck and have a great day.